14.3 is apportionment, and let's start with the definition of apportionment. We want to divide fairly among groups. Now, these examples can get kind of complicated. We're talking about elections and electors and groups and populations and lots large examples. I want to give you a short, simple, silly kind of example first for apportionment. Let's say there's two families. The Smith family has 7 people in it, and the Jones family has 4 people in it. And for some reason, they're going to adopt these 5 cats. So apportionment is, I want to divide these cats fairly among the 2 families. So anybody have a solution to that? How many cats do you think the Smith family should get? 3? That seems logical, right? So maybe the Smith family adopts 3 cats and the Jones family adopts 2 cats. That's kind of a real simple example of what we're doing. It's going to get a lot more complicated because the numbers are going to be bigger. There's going to be more groups. There's going to be more cats. But that's basically what we mean by apportionment. We're trying to divide fairly among groups. We start with this idea of standard divisor. Standard divisor. Standard divisor is the total population divided by the number of items. Total population divided by the number of items. So go back to the cats again. The total population would be 11 people, I guess, right? 11 people divided by the number of items, 5 cats. 11 divided by 5 is, I think, 2.2. And to understand what that number means, think about the units. It was 11 people and it was 5 cats. So that number 2.2 is the number of people per cat. Or flip it upside down. It's 1 cat for every 2.2 people. That should make sense, right? 1 cat for every 2.2 people in this example. That's standard divisor. Now the standard quota is the group population divided by the standard divisor. The population of each group divided by that standard divisor. So we go back to the cats again. The standard quota would be the group divided by the standard divisor. 7 divided by 2.2 is about 3.18, and the Jones family had 4. Divide by that 2.2 is about 1.81. And so if you round off, you can see 3 come out of there, 3 cats. You can see 2 cats come out of there. That's kind of what we're doing. It's a little bit more complicated than that, but that's kind of an idea of where that 3 and where that 2 would come from mathematically. We talk about the lower quota. The lower quota, LQ, is going to be the standard quota rounded down. The upper quota is the standard quota rounded up. The quota rule says a group's apportionment should either be the lower quota or the upper quota. That's the quota rule. So think about the cats. You're going to have to get over rounding to the nearest number because sometimes we're going to round down. And if we round down, that says 3. And if we round up, that says 4. That would be your lower quota and your upper quota. And it's weird to round up, but that's sometimes we're going to have to round up, not necessarily round to the nearest. So your lower quota would be 3 and your upper quota would be 4. Your lower quota would be round down to 1. And your upper quota would be round up to 2. The quota rule just says it either has to be 3 or 4. You're going to give this family either 3 or 4 cats. You're going to give this family either 1 or 2 cats, nothing else. Anything else would be a violation of the quota rule. Number 1, the Republic of Whoville is composed of 4 states. According to the country's constitution, Congress will have 30 seats to divide among the 4 states according to their respective populations. The incomplete table below shows each state's population. So this is a more complicated version of the cats example. I'm talking about population in thousands, and we're going to divide 30 seats instead of 5 cats fairly among those 4 states. We need to find the total population, and so we're going to want to add those 4 numbers together. So here's where you want a calculator. You want to be able to add stuff like that. Those numbers total up to 1890. Now remember, that's in thousands, so that's really 1890,000. And we want to find the standard quota. Well, remember the standard quota was the group population divided by the standard divisor. So we can't find the standard quota until we find the standard divisor. Think about what the word divisor means. The word divisor means we're going to divide by that number. So let's find the standard divisor. The standard divisor was the total population divided by the number of items. So that's going to be 1890 divided by 30. 1890 divided by 30 is 63. So again, to think about what that number means, think about the units in this problem. 1890 was people and 30 seats. So the 63 means 63 people per seat. Or if you flip it, 1 seat for every 63 people. Same thing. All right, but that's the standard divisor, 63. To find the standard quotient, you divide the group population by that standard divisor. So the first one, 275 divided by 63 is about 4.37. I'd round off to 2 decimals, probably good enough. Group B, 383 divided by that 63 gives me about 6.08. 465 divided by 63, 7.38. And 767 divided by 63, 12.17. I don't need to do the total. I don't need to do that other box because I'm not talking about the group population. I'm talking about the total population. If you did it, I mean, it's fine if you do it, but if you do that, you're going to get 30. Of course, that's 30. That's the total number of seats to be apportioned or to be divided fairly. So we haven't really apportioned them, but we have found these standard quotas. Those are the standard quotas. So we're either going to round those numbers up or down. We're either going to round them up or down. And this part B says, what does the quota rule say about this situation? Well, it says A gets 4 if we round down or 5 if we round up. B either gets 6 if we round down or 7 if we round up. C gets 7 or 8. D gets 12 or 13. That's what the quota rule says. Nothing else would make sense. Anything else would be a violation of the quota rule. Notice if you add those numbers up, 4 plus 6 plus 7 plus 12, is that 10, 17? That's 29. That's 29, not 30. So, you're going to have to mix these numbers up somehow so that it adds up to 30, right? There's some combination of these numbers going to add up to 30, and that's how we're going to pass out those seats. But there's 4 different methods for doing it. There's Hamilton's method, Jefferson's method, Adams' method, and Webster's method. And what's difficult, in my opinion, on this lesson is these 4 methods are very, very, very closely related. They're very similar. Hamilton's is probably the easiest. Find the standard quota for each group, round each standard quota down to find the lower quota and assign to its group. Give surplus items one at a time to the groups with the largest decimal part. So there's a lot of stuff going on here. But one thing to notice, this is the only one that talks about surplus or extra items. It's one of the things that makes it different, but it also is one of the things that makes it the easiest one to deal with. All right, I want to summarize this. I want to summarize this box. So let's condense. You are going to use the standard divisor to find the standard quota, but round down. And then you're going to have extras. So if I had to condense all those words down, I'm going to do that. Let's look at Jefferson's method. Jefferson's method doesn't use the standard quota like Hamilton's did. It uses a modified divisor to find a modified lower quota. All right. Now, if you notice, each of the next 3 is going to say modified divisor and modified quota and modified divisor and modified quota. All of these are modified, not the standard. And so what's going to make this difficult is it's going to involve kind of guessing and checking. You're going to have to use some trial and error here. But these 3 don't have any extras. Common mistake that I see when teaching this lesson is people learn Hamilton's method with the extras and they're like, that wasn't so bad. And then they try to do that with the other methods, but you can't. You can't give out extras. There won't be any extras if you've done it correctly. All right. So I'm not going to read all of this. I don't want to. I think it's confusing because they're all almost the exact same thing. So I'm going to summarize, and hopefully you'll see the difference with the summary. Use a modified divisor, not the standard divisor. That's a big deal. Your modified divisor is going to be something that's less than the standard divisor. And so let's go back to the cats for a second. What I mean by that is the standard divisor here was 2.2, right? Your modified divisor, we're just going to have to guess something that's less than 2.2. So 2.1, 2, and we have to divide by that number and find out the apportionment, okay? 2.1 might not be good enough. 2 might not be good enough. We might have to try 1.9 until we can find an apportionment that adds up to whatever it is, 30 seats or whatever our example says, okay? So that, to me, is the hard part. We're going to find the modified quotient instead of the standard quotient and round down. And there are no extras. So if you can do one of those, then you should be able to do the other two because they're very, very similar. Adam's method, we're going to use the modified divisor, not the standard divisor. In this case, the modified divisor is going to be greater than the standard divisor. We find a modified quotient, and this time we're going to round up, not down. We're going to round up this time. And once again, there are no extras. So you can see how similar this method is to the last one. Well, Webster's is almost the same thing. Very similar. Use modified divisor, not the standard divisor. This time the modified divisor is less than or greater than the standard divisor. We don't know. It might be bigger, it might be smaller. We just have to figure that out. It's going to take some guess and check, some trial and error. This time we find that modified quotient, but we round to the nearest number. We don't always round down, we don't always round up, we just round to the nearest, which is what we are more comfortable with anyway. This is what we are used to. We're used to rounding off to the nearest number. That's Webster's. And once again, there are no extras. So don't memorize all of this language here. Try really hard to nail down these, shortened, abbreviated directions. But that's what we're trying to do. Here's example 2. A rapid transit service operates 130 buses along 6 routes. The number of buses assigned to each route is based on the average number of daily passengers per route shown in the table. Use Hamilton's method to apportion the buses. So Hamilton's method, we want to distribute those 130 buses. Not 5 cats, not 30 seats, but 130 buses. We're trying to divide up 130 fairly among those 6 groups. All right, Hamilton's method. Hamilton's method uses the standard divisor. We find the standard quotient, we round down, and pass out the extras. I would probably just go back and jot that down until you're comfortable with it. I don't know that you'll ever have it memorized, but jot that down until you feel good about what Hamilton's method says to do. We need to find the standard divisor. So remember, the standard divisor, according to the definition, was the total population divided by the number of items. In this example, the total population is 65,000 and the number of items is 130. Do that division, 65,000 divided by 130, we get 500. And again, in order to understand what that number means, think about the units in the problem. 65,000 people, 130 buses. So we're talking about 500 people per bus. Or backwards, that's 1 bus for every 500 people. I think that makes more sense. 1 bus for every 500 people, 500 people for every bus. That's what that means. That's what the standard divisor is. So we found the standard divisor. Now we need to find the standard quotients and round down. The standard quotient was the group population divided by the standard divisor. The group population divided by the standard divisor. So we're going to take this number and divide by 500. 4360 divided by 500 is 8.72. And do that all the way across. 5130 divided by 500 is 10.26. Divide by 500, 14.16. Divide by 500, 20.49. Divide by 500, 31.07. Divide by 500, 45.3. And since the standard quotient is the group, I don't need to divide the total. If you divided the total, you're just going to get 130 anyway. That's not helpful, not useful. I'm talking about the groups, the standard quotas. So see those numbers, you're either going to round them up or round them down. So we're talking about 8 or 9, 10 or 11, 14 or 15, 20 or 21, 31 or 32, 45 or 46. The answer has to be those numbers. Anything else would be a quota rule violation. But we are rounding down, right? Hamilton's method says to round down, so round down, that's 8. Forget about rounding to the nearest. We don't want to round to the nearest, we want to round down in this method. Round down, 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 and down. Those are the standard quotas rounded down. Now, somebody with a calculator, add those numbers up. 128, thank you. Perfect. That's not 130. Remember, I'm trying to pass out 130 buses. I'm trying to divide up 130 buses. That's 128 of them. So if that's 128 of them, then you should know, or you should be able to see pretty quickly, that there are 2 extra buses that we still need to pass out to somebody. We have to figure out who gets those other 2 buses. I already know pretty much everything. I've already got 128 of them, but we've got 2 more to give away. And so go back a page and look at the directions for Hamilton's method. That last step, give surplus items one at a time to the groups with the largest decimal parts. That's kind of weird. One at a time to the groups with the largest decimal parts. Weird, but not hard. We look at those standard quota numbers and find the number that has the largest decimal part. See that 0.72 is the largest decimal part? We're going to give that group one of those extras. Just one. The direction said one at a time. Don't give them both out, just give one. Then, which of those numbers has the next biggest decimal? Right, this one, 20.49. So, if there was a tie, maybe you should have rounded to more than 2 decimal places. Just look at all of the decimals to see. But anyway, that's the next biggest. We're going to give that other extra to that group. Those numbers should now add up to 130, and that was Hamilton's apportionment. A gets 9 buses, B gets 10, C gets 14, D gets 21, E gets 31, and F gets 45 buses. Okay, it's not so bad, right? But it definitely gets worse because Hamilton's method is the easiest one. Number 3, we're going to do the same problem, and we're going to do with Jefferson's method. So Jefferson's method. Still passing out 130 buses, but this time it's Jefferson's method. Jefferson's method. We use a modified divisor, not the standard divisor. That modified divisor is going to be less than the standard divisor. We use that modified divisor to find the modified quotient, and we round down. There are no extras. something that people will try to do is they'll do it wrong, and they'll have extras, and they'll try to pass out these extras, but there aren't any. If you have extras to pass out, then you're not finished. You did it wrong. Okay? So modified divisor. Modified divisor. Okay? Well, they actually gave me the modified divisor right here. This makes this problem a lot easier than it could have been. All right, the modified divisor is supposed to be less than the standard divisor. Well, yeah, 486 is less than 500. Remember that? The standard divisor was the total population divided by the number of items. We already did this. 65,000 divided by 130 was 500. 500 people per bus. That's the standard divisor. But in order to get no extras, we have to modify that divisor. We're going to pick a different number that's close to 500. We're going to pick a different number that's close to 500 and divide by that. And finding that number is the hard part, but we find that number that leads us to having no extras. So we would just have to guess. If the modified divisor is less than the standard divisor, we're just going to have to guess something that's less than 500. Well, not in this case, because they told me what to use. They're telling me the modified divisor, but I'm telling you, normally you're going to have to say, well, that's the group. Wait, no. You got to pick something that's less than that 500, and you're just going to have to guess. The modified divisor is 486. So the modified quotient is going to be the group population divided by the modified divisor. If you're ever confused, just go back to think about what the word divisor means. Divisor means I'm dividing by that number. Dividing by that number. So we need to divide these numbers by 486. The group population divided by the modified divisor, and we get modified quotient 8.97, 10.56, 14.57, 21.08, 31.97, 46.60. Notice they're close to the numbers we got before, but not the same. Not going to be the same. They should be close, though. So don't forget, in Jefferson's method, we round down. We will not always round down, but we do in Hamilton's and we do in Jefferson's. So we round down. That's 8, that's 10, 14, 21, 31, and 46. Notice, some people have a really hard time rounding this one to 31. They're like, yeah, but it's so close to 32. I don't care about close. I'm rounding down. I'm rounding down. So if we add up those numbers, 8 plus 10 plus 14 plus 21 plus 31 plus 46, you notice those add up to exactly 130. If they didn't, we won't give out extras. If those numbers did not add up to 130, that's because this number wasn't good enough. We'd have to pick a different number and divide by that number. And so it takes a little bit of trial and error. It's not very fun to do. So this is Jefferson's apportionment. Jefferson's apportionment. A gets 8, B gets 10, C gets 14, D gets 21, E gets 31, and F gets 46.